Hello friends, this video on Fun with Magnets Part 5 is brought to you by examfear.com. No more fear from exam. So let us start discussing about some of the basic properties of bar magnet. So just to keep things simple, we are using a bar magnet throughout. Now it has been observed that if you take a bar magnet, tie it to a thread, and then if you suspend it freely from a stand like this, so you have a stand, you suspend a bar magnet through a thread, and what do you observe? You will observe that the bar magnet always aligns itself in the north south direction when suspended freely. So this is something very interesting. So it doesn't matter even if you rotate it in some other haphazard direction, but after some time it will align itself in the north-south direction. So therefore, looking at the orientation of the bar magnet, you can decide which is north, which is south, which is east, and which is west. So that ways, you get to understand the various directions. Right, so that's how a magnet acts as something which helps us to find directions. Now, just for your own, for your own confirmation, if you try doing the same thing with other objects like maybe a plastic comb or a wooden slab, what do you observe? You observe that they align in different orientations every time. So it is not necessary that they will align in the north-south direction. So that proves that it is an exclusive property of magnets. Now it doesn't happen with every other object. So only magnets have this property. So when you look at different magnets, like in bar magnet, I said that the two extreme corners of the bar magnets are the two poles of it. Like one is north pole, the other one is the south pole. Now what about the magnets of other shapes? For example, we had a U-shaped magnet. So what about the north pole and south pole of this magnet? So one side will be north, the other side would be south. Similarly, when you think of a cylindrical magnet, so in this case, this face can be north, the other face can be south, or this side can be north, the other side can be south. So that's how different magnets are designed. When you think of a ball-ended magnet, again, one ball would be north, the other ball would be south. Now, how do you prove that, okay, these are the two poles? Now, you can perform the same experiment like how we performed with the iron filings with a bar magnet. So you will see that more iron filings get attracted towards the two ends, which show that the two ends are the two poles. So that's how in different types of magnets you will have poles located at different parts. Now we will talk about something very interesting, that is magnetic compass. As I said, magnet is a property because of which it can tell us direction. So using this property of magnet, an instrument is designed which is called a magnetic compass. So this instrument indicates direction, and it is a very simple instrument. I mean, it is not a very complicated or a huge device, a very small device. It looks like the dial of a wristwatch. It is just that here, like in wristwatch, it tells you the time, and here it will tell you the directions. As you can see, this is north, south, east, west. Now inside you have a needle like this, and then this needle will actually tell you the direction. So this needle is placed inside the dial in such a way that it is pivoted inside. Pivoted inside means it is like at the center it is fixed, but it can freely rotate otherwise, like the hands of the clock, maybe you can say. So it's like pivoted at the center and it can rotate freely. And if you look at the dial of the compass, you see that it has directions marked over it: north, northeast, east, southeast, south, and so on. So this entire compass is like a small box with a glass cover. So you can very well relate it to how the dial of your wristwatch looks like. Now, whenever this needle is at rest, it points in the north-south direction. So whenever you keep it at rest, it will always, like, it's the same concept of bar magnet. So the needle is a magnetic needle. So it is a magnet. So the magnet, when left to itself, will align in north-south direction. So it will remain like this. But when you take this magnetic compass near another magnet, what happens? The needle deflects. Why it deflects? Because the needle is magnet and this is also a magnet. So the two magnets, they experience attraction between them, attraction or repulsion, whatever. And because of that, the needle tends to deflect. Also, how do you know which side is north and which side is south? That is why in most of the needles, one side would be red, the other side would be blue, just to distinguish the north from the south pole. So this is how a magnetic compass works. So I hope that with this description of magnetic compass, you would have understood that how the property of magnet, that it can determine directions, turn out to be very useful. Thank you. Please visit www.examfear.com to watch more educational videos with a better experience. Please do not forget to like and subscribe to our YouTube channel for latest updates. Thank you once again.